Has this happened to you before? A couple of years ago, when I first became a senior, I got an email and I couldn't believe who this was from. It was Facebook. Well, Meta, but at the time they were Facebook. And they wanted to interview me. And I couldn't believe it. I was so excited. I was like, I'm going to Facebook. It was for a front-end engineering position. So I was like, perfect. Because HTML, CSS, and JavaScript, like I can write that with my eyes closed. That's, well, not CSS. That's actually really hard. But the rest, I got this. I can write CSS. It's just that, I kind of need my eyes for that. Anyway, I was like so excited. I'm getting this job. So I replied to the recruiter immediately. They called me. We scheduled the interview and I was ready. I was stoked. I was on my way to Facebook. The day of the interview came and I remember it was one of those remote interviews. So I open my laptop, I log in, I'm there. I have a very brief introduction with the recruiter, with the interviewer. And he says, in an infinite chessboard with negative infinity and positive infinity, how many moves would it take the knight starting at 0-0 to get to a position that I give you? And yeah, that's all I remember. I blanked out. I had no idea how to solve that. I was like, infinite chessboard? Like, what are you talking about? Negative infinity, positive infinity? Like, what is this? The interviewer tried to help me, but honestly, like, there was no helping me. I was like super lost. He started mentioning something about nodes, and I was like, okay, I don't know what a node is. The interview ended, and as you could tell, it went pretty poorly. I just remember being like super embarrassed that I like flopped it so hard. After it ended, all I wanted to do was find out the answer. Like I couldn't believe they were asking me that question. I found out that it's called minimum knight's move, and it actually was the thesis of a 14th century mathematician. I couldn't believe people just give you 14th century mathematician's thesis to solve in like 14 minutes. But anyway, after that, I vowed to learn data structures and to be able to solve them and to not be caught in that experience again. And in this video, I'm going to show you what that data structure is so that doesn't happen to you. And all it takes is an infinite chessboard. Let's go check it out. As you can see, it's a medium in LeetCode, so none of those easy ones. And I will explain it further. The first thing I want you to see is that it says infinity and positive infinity, like he told me. When I heard that, I thought that they were trying to get me, but actually that's a hint to the type of data structure we need to use. But before we do anything, we're going to follow the same 3 steps that I use to solve any LeetCode. All right. We're going to diagram, we're going to pseudocode, and then we're going to actually write the code, translating the pseudocode into code. I do it so that you can write in whatever language you like. All right. So let's first start with diagramming so that we can understand the problem. In order for us to check all the moves the knight can make, we're going to have to keep track of them. The best data structure to keep track of them is a queue. Much like waiting in line or waiting in a queue if you're not from the United States, a queue allows you to check first in, first out. So the first person to show up to the queue is the first person that gets attended. So let me show you how this works. So first we create a queue and we add to the queue the position of the knight, which we are at X and 0, X being X coordinate, Y coordinate, and 0, we're going to keep track of how many moves we've made. So it starts at 0 because we haven't made any moves. Now, we know that we have to make 8 moves because those are the 8 moves the knight can make. So we're going to populate our queue with those 8 moves. So we know we have to move to 2 X, 1 Y, so on and so forth. We populate the queue. Once we populated the queue, we take the first one. We've populated it with 0, so we check for that. Is X 2 and Y 1 here? No? Okay, so we don't worry about that one. Then we take the next one. Is X 2 and Y 1? Yes. How many moves was that? 1? That's our answer. 1. It took us 1 move. All right. Now let's do the same exercise with a slightly more complicated one. So let's check out example number 2. Instead of being asked to check how many moves it would take us to get to position 2, 1, they're asking us to check 5, 5. So let's see how that goes. So we would follow the same pattern, which we would populate our queue with where we are, 0, 0, and we've made 0 moves. Then we also populate the queue with all the 8 moves that the knight can make from that position. Seeing here. After we do that, we pop from the queue, we unship from the queue, and we check to see if we're at the desired location. So 0, 0, are we there? It's 5, 5. Nope, we're not. Then we unshift again. 2, 1, are we at 2, 1, 2, 1? It's actually 5, 5. We're not. But before we can dismiss it, we then have to go to all the places that knight can move to, which is all these places over here. And we're going to continue to do that for all the other different places that it can go. Now, I'm not going to populate all of it because it gets kind of crazy, but I want to show you one thing here, which is, as you can see, once we populate all the places that this knight can go, it actually will tell us to go to 0, 0 again, which we've already been there. And that will continue to happen. Many of these knights will go to the same blocks, right? This one right here is going to 0, 0 again, so we would have to go there like twice. And if we put this one here, it's going to 0, 0, but it's also going to this 1, 3 that another knight went to. So in order to avoid having to go to all the places that we've already been to, and we know they're not the actual place, we're going to keep a map of all the places we're visited. We're going to call that map visited. And if we haven't been there, then we'll populate it to add it to the queue. Otherwise, we don't, because we know we already checked it and it doesn't matter. Okay. And then we're going to continue that same effort. Then we're going to eventually go here and we're going to continue to populate until we know that we'll get to our desired place, which is here. And if we continue that effort, we can see that it takes the knight 1, 2, 3, 4 moves to get to the desired location, which is exactly the answer. All right. So this one gets kind of hairy. I hope it makes sense that it can go 8 times. We check it if we've been there. We don't. But let's write the pseudocode to make a little bit more sense of this. So let's go to that part. Great. So the first thing we'll need is to have our queue. So let's add that. And then we'll also add that first position, the knight being at 0, 0, and the number of moves, which is 0, to our queue. The second thing we'll need is to keep track of whether we've visited that before or not, so that we don't go to the same locations over and over again. So we can use a map or a set and we can just hash it. And at the same time, we're going to add that location as a hash set of 0, 0. With those two things in place, then we're going to go through our queue. So while we have items in the queue, we're going to go through each one and we're going to grab the first one. Once we have the first one, we're going to check to see if that is the input, if we are at the location that was asked of us. If it is, we're going to return the number of moves it took us. If not, we need to go through all the 8 moves that knight can make. Then we're going to go through all those 8 moves and we have to check whether we've been there or not. The way that we're going to check whether we've been there or not is by creating a hash and checking to see if we've been there before, if we've seen that hash before. If we haven't seen that hash before, then that means that we haven't been there, and so we can add it to the queue. And that's it. That's our pseudocode. Now let's translate this into actual code and run it to see if we succeed. Let's go. Now let's write the code. That's the easy part. We're just going to translate our pseudocode into our code. I'm going to use JavaScript, but feel free to use whatever language you prefer. So the first part, create queue and add first position and number of moves. Second, add first position 0, 0 to set. While we have items in the queue, get the first one and call it nx, ny, and moves. Check location against the input. If the same location, return number of moves. If we didn't get the correct answer, then we need to add all the 8 moves that the current position can make. Then we go through all the 8 moves and we have to create the visited hash because that's what we're going to use in order to determine whether we've been there or not. And then we check if we have seen that hash before, if we've visited before. If we haven't been there before, then we add it to the set and we add it to the queue. We have to remember also to make sure to add 1 to the number of moves we've made. And that's it. That's the code. Now let's see if it runs. There it is. Awesome. Minimum knight moves. Make sure you study this one so that you get hired and get the job you want. Anyway, thanks. Till the next time.